Hello my dear students, welcome back to the one more session of structure of atom. So in the last session we have studied about the Bohr-Bury rules and atomic number of different elements. In this session we will learn how to write the electronic configuration. So before that we will see how an element is represented. Okay. Suppose if you take X an element, so here the atomic number of that element is written down. So the atomic number, it is denoted by the Z. It is denoted at the downside. It is called as subscript. Subscript means it is written down. And A is the mass number. Mass number is denoted by the A. It is written as the superscript. Superscript means you will write it at the top. Okay. So atomic number is written at the bottom and mass number is written at the top. Take for example, if you want to write carbon, so you should write the symbol. What is the atomic number of carbon? It is 6 and mass number 12. So you should write it here. So this is how the element is represented by atomic number and mass number. You can take one more example. Oxygen. Oxygen atomic number is 8 and mass number is 16. So you will write it here 16. Okay. Take one more example. Nitrogen. So nitrogen is N. Atomic number is 7 and the mass number is 14. So likewise you should represent an element. Clear? Next we will see what is electronic configuration. So electronic configuration is defined as the distribution of electrons into the orbitals of an atom. So you know how the orbitals will be. Center nucleus will be there. Around this the orbitals will be there. Different orbitals will be there. So the electrons will be revolving in the orbitals. So how these electrons are arranged, so that is the electronic configuration. Okay. So every neutral atom, it consists of the fixed number of electrons. Okay. So the number of electrons is equals to the number of protons. This is the atomic number. You know what is atomic number? The number of protons is the atomic number. Here number of protons is equals to number of electrons. Okay. So we'll see how the electrons are distributed of different elements. Take for example hydrogen. Okay. So you know what is the atomic number? Atomic number is 1. So the electronic configuration is only 1. And helium, the atomic number is 2. So in the K shell you should write 2. So only 2 electrons are there. So it is only 2. Lithium, the atomic number is 3. That is the 3 electrons are there. So how do you represent? First the K shell should be filled. Next L shell. Next M shell. Next N shell should be filled. So first we will fill the K shell. So how many maximum of electrons can be filled in the K shell? It is 2. Only 2 electrons can be written. So we will write it here 2. But in lithium there are totally 3 electrons. So comma. So 3 minus 2 is 1. 1 electron is remaining. So that will be filled in the L shell. So 2 comma 1 is the electronic configuration of the lithium. Okay. Next element you take beryllium. So beryllium atomic number is 4. Okay. So first K shell you'll fill 2 electrons. So how many are remaining now? 2 are remaining. So 2 comma 2 is the electronic configuration of the beryllium. Okay. Next you have boron. So atomic number is 5. So how do you write the electronic configuration? It is 2 comma 3. 3 plus 2 is equal to 5. So 2 comma 3 is the electronic configuration of the beryllium. And next carbon. Carbon atomic number is 6. So totally there are 6 electrons. So how do you represent? 2 comma 4. Okay. Next you have nitrogen. Here it is 2 comma 5. Atomic number is 7. So it is 2 comma 5. And next you have oxygen. So oxygen atomic number is 8. So totally 8 electrons are there. It is 2 comma 6. If you take fluorine, fluorine atomic number is 9. 2 comma 7. So this is the electronic configuration of the fluorine. Next if you take neon, neon there are totally 10 electrons. So it is 2 comma 8. Okay. So this is how you have to write the electronic configuration. So we'll see some more examples. We'll take sodium. Sodium there are totally 11 electrons. So first 2 will be filled, 2 comma. So in the K shell maximum how many electrons you can fill? 2 electrons. And in the L shell maximum number is 8 electrons. So you know how to find out the maximum number of electrons. It is found out by the formula 2n square. Okay. So in the L shell maximum how many electrons can be filled? 8 electrons can be filled. But in case of sodium there are totally 11 electrons. 8 plus 2 is 10. So 1 electron is remaining. So that we will fill in the next shell. So 2 comma 8 comma 1 is the electronic configuration of the sodium. Next is magnesium. So magnesium has 12 electrons. So how do you fill? 2 comma 8. So 8 plus 2 is 10. How many are remaining? 2 will be filled in the next shell. Okay. This is the K shell, this is L shell, and this is M shell. Okay. Next we have aluminium. Aluminium, it has totally 13 electrons. So 2 comma 8 comma 3 is the electronic configuration of the aluminium. Next you take silicon. So what is the atomic number? It is 14. So 14 means 2 comma 8 comma 4. Okay. Next element is phosphorus. Phosphorus is 15. So 2 comma 8 comma 5. And next sulfur. Sulfur is 2 comma 8 comma 6 because atomic number is 16. You have chlorine. Chlorine atomic number is 17. So 2 comma 8 comma 7. Next comes argon. Okay. So the atomic number is 18. 2, 8, 8. Okay. Next, potassium. See this potassium, you observe. Potassium atomic number is 19. So you can write 2, 8, next what you can write? 9? No. You cannot write 9 here. You should write 8. Okay. So in the L shell, you should write 8. So one more electron is remaining. So that electron should be filled in the next shell. That is 1. So 2, 8, 8, 1 is the electronic configuration of the potassium. Here why? Because in the L shell, you know the maximum electrons can be filled is 18. But you cannot write here 8. There is some logic. So that logic you study in your higher classes. But as if now you remember that in the L shell you should write 8 electrons. You cannot write more than 8. But if anyone asks you how many maximum electrons can be filled in the M shell, you should tell it is 18 electrons only. Okay. So next, calcium. So if you see calcium, the atomic number is 20. So it will be 2, 8, 8, 2. So this is the electronic configuration of the calcium. Okay. So up to calcium, you should be knowing the atomic number and also the electronic configuration of 20 elements. Clear? Okay, we'll stop here. We'll continue in the next session. Thank you.